we're going to look at solving some linear equations. So first off, what is a linear equation? A linear equation is an equation that can be written in the form ax plus b equals 0, specifically where your variable is being raised to the first power. So it might not be in that form to start with, could be something like 3x plus 5 equals -4. But if you can put it in that form, which this one I could add 4 to both sides and end up with 3x plus 9 equals 0, as long as your variable's to the first power, that's a linear equation. Two equations are equivalent to one another if they have the same solution. So say you have something simple like x plus 2 equals 4, and another equation like 2x plus 4 equals 8. Those two equations are equivalent because if you solve them, in both cases, you're going to get the same solution, x equals 2. Let's look and see if these equations here are linear or nonlinear. So if you look at this first one, it's got my variable being raised to the first and second power. So this is a degree 2 equation. It's quadratic. It is not linear. So nonlinear. If you look at part B, well, sometimes it helps if you want to multiply some things together here and rewrite it in that form ax plus b equals 0. I could multiply my 12 by x plus 2, and then I would be able to subtract 12x and 24 from both sides and get it in the form ax plus b equals 0. That one is linear. My variable is raised to the first power, and I just have some other constants in there. All right, let's do some equation solving. If you take this first equation here and multiply your 4 times my 2a minus 3, I'll get 8a minus 12 equals, and then over here on the right-hand side, I'm going to go ahead and multiply my -1 times both a and 2. So I'll get 15 minus a minus 2. Now, if my variable's on both sides of my equation, I want to go ahead and isolate it on one side. So I'm going to do a couple of things here. First thing I'm going to do is I'm going to go ahead and add a, because -a plus a would get me 0a. And then while I am at it, this left-hand side here is going to be 9a minus 12, and then over here I have 15 minus 2, like terms on the same side that I'm going to go ahead and combine and get 13. Now I'm going to add 12 to both sides so that I just have my term of 9a by itself here, because that gives me 0 when I add 12 to -12. And then to get 1a, I'm going to divide both sides by 9, so I'll get a equals 25 over 9. This equation involves a lot of fractions. So one option is if you multiply both sides by your least common denominator of all three of these fractions here, I could get rid of all of the fractions through that multiplication before I start. So least common multiple of 2, 3, and 4 would be, if you list them out, 2, 4, 6, 8, 10, 12, 3, 6, 9, 12. If you list out all of the multiples until you get to the multiple they have in common, it's 12. So I could multiply both sides of this equation by 12 to start with and no longer have any fractions involved. So actually, I'm going to show you what it looked like if you did that, which if you multiply by 12, you have 12 times 2x plus 1 over 3, and then 12 times 1/2 x equals 1/4 times 12. It is easiest if you reduce before you multiply things together here, like this 12 divided by 3. If you go ahead and make it into 4 and then multiply and get 8x plus 4 all over 1, or just 8x plus 4. And then here I could divide 12 by 2 and get a 6x. And then over here, 12 divided by 4 is going to give me 3. So that's one option. It got rid of all of my fractions. And then I could just combine my like terms that are on the same side here and end up with 14x plus 4 equals 3. Subtract 4 from both sides, and then divide by 14 to get x equals negative 1/14. That isn't the only option. I could choose to get a common denominator just between these two fractions on the left here by multiplying by 2 over 2 and 3 over 3, and then adding them together and working on writing it as a single fraction before I proceed. There's lots of ways that you could solve it. If you look at part C down here, if I'm solving for h, it's tempting to kind of get into the habit of, oh, I'm going to just go ahead and distribute this anytime I see it here. But if you do that here, look what's going to happen. Now you have the variable you're solving for in 2 terms instead of just in 1. So that's kind of the opposite of what I want to happen. I'm trying to get my variable by itself. So I don't really want to distribute that 1/2 h. What I'm going to do instead is go, okay, I'm trying to get h by itself. This is 1/2 h. Why don't I go ahead and multiply both sides by 2? Or thinking about undoing that division or that multiplication of 1/2, you could divide by 1/2, multiply by 2. Then you'd have 2a equals 1h times b sub 1 plus b sub 2. And then that h is being multiplied by this entire quantity, b sub 1 plus b sub 2. So if I divide both sides by that, I'll have h by itself. So I could have 2a over b sub 1 plus b sub 2 equals h. If I have an equation that has the variable that I'm solving for in more than one term, like here I'm solving for y, and it's in both of those terms, I need to go ahead and factor it out first so that I can isolate it and get it by itself. So if I factor y out here, I'm going to have negative 3x plus 2. And then, since I have y multiplied by that quantity, I can just divide both sides by the quantity negative 3x plus 2. And that's what y is going to be equivalent to. You may not necessarily have one where all the terms with the variable you're solving for are on one side to start with. So if you look at like b here, I'm solving for x, and I've got x's here, here on both sides of my equations. So I need to get everything involving the variable that I'm solving for together on one side. So I'm going to go ahead and work on that by multiplying my 3 in. And then I'll rearrange it so that my variables with x are together on one side with nothing else. So I'm going to go ahead and go subtract 6x from both sides so that I get everything with x's on the right-hand side of my equation. And while I'm at it, I'm going to go ahead and add 2 to both sides. So I'll end up with 4ax minus 6x on the right, and negative 15a plus 4ab plus 2 on the left. Okay, now I'm kind of in the case where I was before, where my variable I'm solving for is in 2 terms. So let's factor that x out, which leaves me with 4a minus 6. And then if I divide both sides of my equation by 4a minus 6, I'm going to have x by itself. So it's not going to be the prettiest solution in the world, but life's not always pretty. So you end up with x equals that expression. There are 3 different types of linear equations: identities, conditionals, and contradictions. So the type that you're used to solving that you just did up above are what are called conditional linear equations, where it leads to a single specific solution. So basically your equation is true under the condition that your variable has some specific value. If you have the equation like 2x plus 4 equals 8, that equation is true under the specific condition where x equals 2. You also have kind of special case type of equations, identities and contradictions. So an identity is an equation where it always results in a true statement, something like you get 3 is equal to 3, which is true all the time. So if your equation looked like, say, 2x equals 2x. Well, it doesn't matter what x value you have in there. Both sides are always going to be equal to each other. So that equation is an identity. You can also have contradictions where you have no solution. It's not possible to come up with a value that's going to make your equation true. If you end up with some statement like, say, -2 equals 7, which is not a true statement when you solve, then you're working with a contradiction. Say you have like 2x plus 1 equals 2x. Well, if you try to solve that for x, there's no way you can get both sides to be the same. If you subtract 2x from both sides, you end up with a statement 1 equals 0, which is not possible. So you know that's a contradiction. So if I was going to give an example of each one of these, I could do the identity. Well, I'm going for 2x here. 2x plus 4 equals 2x plus 4. I could write a conditional equation that's like 2x plus 4 equals 8. And a contradiction could be something like 2x plus 4 equals, let's get a little fancier. Sometimes you can't quite tell until you simplify a little bit. Let's say 2x plus 2 times the quantity x plus 1, which if you multiplied that out, you can see you'd get 2x plus 2 equals 2x plus 4. And if you try to solve, you end up with the contradiction 4 equals 2.